All right, so this is kind of getting a little obscure, but let's give it a go. We are asked to determine if the intermediate value theorem, also called IVT, guarantees there is at least one real zero, also known as at least one real root, on the interval from e squared to e cubed for this function. All right, watch. I'll give you the 10-second version of the IVT and you'll get it because you're wicked smart. Look, do we agree that if we have a function that is continuous, and that's important, it's continuous, and I'm going to say it's continuous on some interval from a to b. I'm just making these numbers up. If you plug in a to the expression and you get something positive, and then you plug in b to the expression and you get something negative, does it make sense to you this function has no choice in the matter but to cross zero? At some point, it has to go through that x-axis. Watch, it can't not. It can't connect those dots and not do so. It's like, no, I'll just go, shit, there we go. I got to do it, right? You got to connect those dots. It's unequivocal, no way around it, all right? Now, the kicker, though, is it has to be a continuous function. Be careful. If there's an asymptote between them, then it doesn't necessarily have to work, right? Things can go crazy. Moreover, if you get either two positive numbers, let's say, or two negative numbers, no, there's no guarantee that it necessarily has to cross zero. It's only the exact circumstance that I started off with, which is it's totally continuous. And if you plug in one number, you get positive, and then you plug in the other number, it's negative. And of course, which one's positive and which one's negative doesn't really matter. So if I come right up here, let's take a look one more time, and let's see if the IVT guarantees that there is at least one real zero for this function on that interval. Well, look, here's what I would do. Again, we're looking to be ballers here, right? We're looking to just make our paper look glorious. So I'm going to write here number one. You don't have to label it as one on your paper. I'm just letting you know the first thing that I would say is this. F of x, which is the ln of x, all minus e, is what? Continuous on the interval from e squared to e cubed, right? How do I know that, by the way? Well, think about what the ln of x looks like. The only place where it's discontinuous is from 0 on down, right? In other words, you can't take the natural log of 0 or any number below 0. So in other words, from above 0 up to infinity, it's perfectly fine. E squared, don't forget, e is about 2.7. So from e squared, it's fine. E cubed, again, 2.7 cubed, it's fine. It's only if you hit 0 or negative numbers that it wouldn't be continuous. So what you're doing is you're communicating to the person reading your paper, hey, guess what? I know this guy's got to be continuous for this to even be under consideration. Then your next step is to plug those two numbers in. Like legitimately, what do you get if you get the f of e squared? Well, let's see. That's the ln of e squared minus e, right? What is the ln of e squared? That's just 2. In other words, what exponent do you have to give e to make it e squared? Pretty confident a 2 will get the job done. So that gives us 2 minus e. Now let's be careful here. I don't care what the number itself is. E is about 2.7. If I do 2 minus 2.7, what do I get? The answer is a negative number. Does that make sense? Like the number itself doesn't really matter. I just care about its sign, S-I-G-N. What about this guy? F of e cubed. Well, that's going to give us the ln of e cubed minus e. Ln of e cubed, as you might imagine, is 3 minus e. Now look, 3 is a touch above e, which we agreed e is 2.7 or so, right? So what's this going to yield? The answer is a positive answer. Because it changed signs, it went from negative to positive, the what's called intermediate value theorem unequivocally does agree that there is at least one real zero on the interval. Had they both been positive, let's say, you got to go, sorry, kind of shoulders up, it does not guarantee it. If it was two negatives, same deal. Sorry, there's no guarantee. But if it goes from negative town to positiveville, we know that there is guaranteed at least one real zero. So I would say, therefore, the IVT guarantees. And I cannot spell guarantees for my life, so I'm going to go with that, which I know is misspelled. The IVT guarantees at least one real root on the interval from e squared to e cubed. Therefore, the IVT guarantees there is at least one real root on the interval from e squared all the way up to e cubed. Now, speaking of obscure, let's go over this nonsense. Let's try a weird limit. Okay, and again, these things are, just think of these as like outliers, right? This is just like out there question. And the way you can recognize it is as follows. Let's look here. Let's evaluate the limit as x approaches 0 of the expression x cubed times the cosine of 1 over x. And hint, use squeeze theorem. By the way, squeeze theorem is sometimes called the sandwich theorem. Same deal. Here's the way it works. You can't evaluate that right now. You can't plug in. You can plug in 0 here if you like. Congratulations. You cannot plug in 0 there. And because you can't plug it in, you can't just summarily claim the answer is 0. Okay? That'd be convenient, but it just doesn't work. So instead, what you have to do is this. What we have to do is we have to use what's called squeeze theorem. Squeeze theorem has 3 steps. Write down what you know. I'm sorry. Then let it grow. And then finally show. I know it rhymes. Isn't that adorable? So here we go. First step, write down what you know. What do you know? I'll tell you guys, the way these questions tend to be written, about 4 times out of 5, the thing you know pertains to the trig function. So do we agree with the following? Either sine or cosine, doesn't matter. The cosine of anything, think of the graph of a cosine. It goes and oscillates between y equals -1 and +1 all day. Do we agree? So the cosine of anything is bound between -1 and +1. Do we agree on that? That's step 1. That's my know. That's what I know. I take a piece of the function and just say, ignoring everything else momentarily, I know that that's true. Then what do? Then you let it grow. In other words, you rebuild it back to its original form. It wasn't cosine of 1 over x, but rather it was cosine of 1 over x, whole darn thing, multiplied by x cubed. So you go, okay, fine. Here, I'm going to multiply this by x cubed, and this by x cubed, and this by x cubed. You see the pattern? You're going to rebuild the middle to be eventually x cubed times the cosine of 1 over x. But all is fair. You got to do it to the other left and right side as well. So now where does that bring us? Well, the left side is just negative x cubed. And the middle is x cubed cosine of 1 over x. Okay. And the right side is just positive x cubed. Sound good? Now look, what was the whole point of this example? The whole point was to evaluate the limit as x goes to 0 of the stuff that is now in the middle. So look, I'm going to rewrite this. I'm going to rewrite the middle. What is the limit as x approaches 0 of the stuff in the middle? Let's see. It's the x cubed cosine of 1 over x. What is the limit as x approaches 0 of that? I don't know. But I'm going to do the limit as x approaches 0 of the stuff on the sides. You see, what is the limit as x approaches 0 of negative x cubed? And you know what, while I'm at it, let me also figure out what is the limit as x approaches 0 of positive x cubed. What does that give you? Well, look, on the left, if you plug in 0, what's it going to give you? It's going to give you 0. On the right, if you plug in 0, what does it give you? It gives you 0. So, I have no idea what the limit as x approaches 0 of x cubed times the cosine of 1 over x is. But it sure as hell is somewhere between 0 and 0. Oh, it's 0. Does that make sense? Like, that's the way squeeze theorem works. The sides will always converge upon some number, and therefore you still don't know what the middle is, but it's got to be what? Therefore, this has got to equal 0, and now we are done. There you go.